last lesson? Who can remind us? What were we looking at? Inverse. Right. We've got inverse, and can you remind us what are we talking about when we look at inverse functions? Blah, 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 blah. What was that, Bobs? One-on-one function. Okay, so for a function to have an inverse, it has to be a one-to-one function. I go, you'll see my shorthand, 1, 2, 1, but really you should write 1, 2, 1. Now, what does the one-to-one, how do we know something is a one-to-one function? Dan? Right, so we know, we've seen before that for a graph to be a function, it has to pass the vertical line test. For it to be a one-to-one function, it has to pass the horizontal line test. In other words, it can only cut that horizontal line once. Okay? What about the geometric properties? How would we find the inverse or sketch the inverse? Jado? How do we sketch an inverse function if it exists? Right, that was my hint. What's that? Reflection. So it's a reflection. Reflection in the line y equals x, and that then leads to Moses. How do we find it algebraically, the inverse function? Yeah, Mac? Right, you swap your x and y values and then you try and get y by itself, right? So I would be expecting that some of you, I mean, maybe you're too jolly good for me and I better pull my socks up. I'm wearing socks today. But I thought you might be asking me about 12 maybe. 12? Oh, so what's the key? What's the catch for when you are trying to find the inverse of a quadratic? Wait, are we listening? How do we find the inverse of a quadratic? Did you get to that, Haydo? What did you do? Yeah, but how do you find the equation? I'm coming to you because this is my check instead of coming around and checking. So if I had y equals x squared, what shall we do? Minus 6x plus 4, and I said find the inverse of that. So did you see the inverse stuff the other day? No? So it's quite nice that if we've got y equals, let's go 3x take 2, to find the inverse, all we have to do is where the y is, we put the x, equals 3y take 2, and now we rearrange to get y by itself. Quite simple, right? So 3y equals x plus 2, therefore our inverse function is x plus 2 over 3. Oui? And we go, yeah, no worries. And then you get a quadratic. Now if you go, let's just switch. We get x equals y squared take 6y plus 4. How are you getting y by itself? Shh. What? And what? So if you are factorizing it, what do you mean? Even if you factorize this, you'll get something like that and you're still not going to get y by itself. So this is telling me some of you have skipped, and this is where you do want to make sure that you are doing majority of the questions. So the tip is, no. So some of you might have forgotten. The tip, I would say, is number 13. Because if we look at 13, y equals x plus 1 squared plus 3. So I would have, we'll do it over here. So question 13, I've got y equals, and I've forgotten what it was, but we'll make it up. Oh, thanks. Right, I now go to do my inverse. Okay, so we switch. And you go, no worries, I can get y by itself because the 3 comes over the other side. That equals y plus 1 squared. To get rid of the squared, I will square root. And to get rid of the plus 1, you take 1. Aren't we right? Watching? Tune in. Give her a nudge. Right? It works. But what's the problem when I've got it like this? I've switched my x's and y's, but I've got too many y's. So what is the thing that you have to do, peeps? Right. So when you, and this is something that I might put as a reminder on your notes. So when you've got a quadratic, right, to find your inverse, so inverse of quad, make sure you complete the square first. Yeah? Little note to self. When it comes time for your test next week after, right? You want to make sure that you're remembering this because we're going to have a few things chucked at you. So e.g., let's have a look at this one that we have. We've got y equals x squared take 6x plus 4. And I know it's been a while, but completing the square will come back to you. Yep, so Mac is going, he's looking here. He can see that obviously you need to have a 9 to make that a perfect square. So he's added 5 to both sides. My mind just works a little bit differently. I just go, well, I want to replace that. I divide by 2. I get the x squared. When I expand it, I'll get the minus 6x. But then I've also added on, well, I've added on 9 by writing this like this. So I take 9. But that's going to be the same thing, I think, if you went the 5, 5 either side, because 4, right? So we've now got y equals x take 3 squared, take 5. And if anyone needs more help with completing the square, see Mac or myself. Oh, both Macs. Both Macs. And now you can definitely rearrange this. So now to get your inverse, and again, it's notation, notation, notation. So it helps if you're now saying, okay, now I'm doing my inverse. So now I switch up my x's and y's. So it becomes x equals y minus 3 squared, take 5, and then you can rearrange just like we did before. The 5 will come over the other side, blah-de-blah-de-blah-de-blah. What's the other bonus for putting it in completing the square form? I know the vertex. Why do I need to know the vertex? Well, let's again think about, they just said, I don't know. Think about what our quad looks like. So what have we got? 3 minus 5 is our vertex. Oh, that's not very good, is it? Oh, no, that's all right. That's all right. Y-intercept is 4. That's good. That's good. Jeez. So what did we say at the start of the lesson? Is this a one-to-one function? No. Why not? Because it doesn't pass your vertical line test, right? It's going to cut it twice. So knowing the vertex, we can now say, well, it can be one-to-one. That part there. And of course, we could have chosen the left, but most people, we just like to, I don't know, to the right, to the right. So this would be when x is greater than or equal to 3, it will be 1-to-1. So we've changed its domain and made it 1-to-1. So when it's a quad, let's look at complete the square. It helps us with our domain, and it also helps us to find the inverse. Huzzah? Hey there. So we had a question about number 6. What exercise is this? 3. 3B. 3B question 6. And we're going, well, what's the deal? How do we even plot it? I mean, you could plot and then you'd see, oh, if a horizontal line goes through, that's fine. But if you think about it, let's go right through here. This point here would be 0, 4, and then this point here would be stage 2 mathematics. This point here would be something, so I don't know, let's go 7, 4, but you can see it's got the same y value but different x values. So that's not going to pass the horizontal line test. Thank you. I lost the word horizontal there for a minute. And similarly, if I had a circle and I've got a line that's going through, this would be, well, it's going across, let's say 2 going up to 5, and this one is 2 minus 3. It's got the same x point, so then that's not going to be an actual function. So you don't have to just have a picture of it. If you have a situation, so have we got that happening? That seems okay. Thank you. So yeah, B, we can see here, same y value, different x value, so that's not going to pass our horizontal. Does that make sense? So you don't have to draw it, just observe the points. Any other? There's silence in the crowd. So people are having a little bit more time. I'll give you a bit more time to finish. Who has finished? Oh, all right. No, that's fine. So finish your inverse functions. They're going to now ask you to look at the reciprocal. And remember, we talked about this the other day, that we don't want to mix up the inverse and the reciprocal. Oops. Recip. And we know that we've got f to the minus 1 is not equal to 1 over f of x. And let's also remember our trigonometry, because if we've got the inverse, so we've got sine to the minus 1 of theta, right, which is also referred to as arc sine, right, because we don't want to actually mix this up with the reciprocal. Okay, so sine to the minus 1 is different to 1 over sine theta, because what is 1 over sine theta? Do we remember? Cosec. That's right. So cosec, which, you know, ends up being with the, what are they called? Asymptotes and what have you, different to this. So I think that's why we're going to start referring to this inverse of sine theta as now arc sine, and not talk about to the minus 1 anymore, because it's going to get us confused with the reciprocal functions. So it comes in a little bit more later on, but anyway, that's that bit. You're going to start off looking at something, a constant, and let's just start with 1 over a linear function. So as an example, and you don't need to write this stuff down because I'll show you in a minute where it is, but if you wanted to, that's fine. But just save you a bit of time. Let's have an example of 1 over, keep it simple, x take 3. As soon as you see a fraction, what should you be thinking about when the function is defined?
Asymptotes.
Asymptotes. Am I recording? Yes, I am. What do we mean by asymptotes?
When x is equal to 3, or x can't equal anything less than 3.
So when your denominator can't equal 0, and absolutely in this case, this would be vertical asymptote, x equals 3. How do we denote an asymptote on the graph? Has to be a dotted line, right? So I already know if I'm looking at this would be with a ruler, obviously. X equals 3. And you'd make sure that you'd label it. And again, don't worry, I'm going to show you an example in a minute. X equals 3. Now, what about, is there a horizontal asymptote? Yes. Now, this is what we talk about. Because this is little over big, your horizontal will always be y = 0. Okay? And you might be going, yeah, but what happens if that's like 10? Is that still little over big? Yes, because we're looking at x keeps getting bigger and bigger and bigger, or massively negative. So it keeps on going and going and going. Now, you can use your calculator, but we know that this will sort of look like it's an arc and it's an arc. That's a little bit dodgy, actually. I would take marks off for that because it looks like it's coming down. So try to make sure that it's nicely arced and arced. And of course, your calculator will show you this. It will not show you the asymptotes. You need to know that they are there. And of course, you need to make sure that you label and Tell me if this is brand new stuff, but if we are discussing, we're discussing the behavior of the graphs near its asymptotes. Did we do this? Do you know what that means? So, this is saying as x is approaching infinity, in other words, as x is getting bigger and bigger and bigger, what value is the graph, aka y, what y value is the graph approaching? So we go 0, and yeah, it's coming from above. So you can either write a or plus. As x is approaching negative infinity. All right, so now we're going like this. What's happening? Y is approaching 0, but now it's from below. You could write a b or a negative. Does that make sense? There's one more asymptote that you have to discuss, and that's this one. So as x, as x is approaching 3 from the right, positive. You wouldn't want to be left-handed. Who's left-handed in here? Because we're saying from the left negative. It's implying left is negative. That's not very nice, is it? How rude. Anyway, as it's coming from the right, what's happening to the y values? It's approaching infinity. And of course, as x is approaching 3 from the left, negative infinity. So that's what we call by discuss the behaviour near the asymptotes. Okay? You don't have to write sentences or anything, it's just words. And you think, oh, that's nice. This is 1 over a linear. We're talking to the lads at the front before. What happens if it's 1 over a quad? How many vertical asymptotes do I have then? Don't say. 2? Always 2?
Not always 2.
Why not always 2? Quadratic, it's got a squared. It has 2 solutions. Does a quadratic always have 2 solutions? No. What other types of solutions can it have? Mystery voice.
Imaginary.
Right. So if it's imaginary, that would mean no real solutions. So it could have no vertical asymptotes. Can someone give me an example of when a quadratic would have no solutions? When would a quadratic have no solutions?
When the discriminant is
less than 0. So like, what about x squared plus 4? I can't factorize that nicely without using imaginary. So 0 or 2? Or 1 if it's a perfect square. Okay? But it comes down to the same principles that your vertical asymptotes are going to exist when the denominator is equal to 0. We know that, right? Okay. What about our horizontal? So, when, one that I prepared earlier, this is on Daymap. When we have same on same, so linear on linear, That is when it would just be A over C is your horizontal. It's the leading coefficients divided by each other. Same as when we have quadratic, when it's quad on quad. So if we had, let's say, if I had 3x squared plus bloody bloody blah all over, ooh, that's not very good, all over 6x squared plus la 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 la, what would be my horizontal asymptote in this case? 3 over 6, aka y equals a half. Yeah? If it was cubic over cubic, same thing. So if that was cubic, y equals a half. However, when we've got linear over quad, so we've got small over big, it's always going to be y equals 0, your horizontal asymptote. So small over big, always equal to 0. For a big over a small, so this one and this one, well, guess what? You could actually have OA, which stands for oblique asymptote. So it's a diagonal asymptote. What do they look like? And how do we get that? Synthetic division. So the stuff that we've done before starts coming into. Now, this I've taken from an old textbook, and don't think, oh my God, these problems are massive. All of this stuff here with the derivative, you don't do that. All you have to do is find the asymptotes, and you can find the max and min using your graphics calculator. Yeah? Make sense? So even when we were looking at, what's this one? Linear on linear, I reckon we could look at the example. So linear on linear, I can see already this is going to be y equals 2 because it's 2 over 1. But if they want you to put it in this form, well, use your synthetic division, short, sharp, shiny. It's 2 here, and your remainder is minus 7, so it's minus 7 over x plus 2. So again, you're seeing how some of that earlier stuff is now coming in to our graphies. Does that make sense? All right, so I will cease. And reciprocals, we're looking. I don't think you need to do the graphy meisters. I'd be looking at your calculator. As well as, remember, your calculator is not going to draw your, what's that called? Asymptote. So use technology to help you with these. Okay? Psst. Thank you. The rational functions. You're having a little bit of a read, but, oops, that's me. I screenshot it. Sorry, I was listening to music this morning. Bad Ange. That was really loud. It goes loud. Ooh, hello, Finn. That was my phone going off. All right. Sorry. You can confiscate it. It's going through and it's showing you how to do. So all that stuff we talked about, you don't need to write it all down because it's beautifully here for an example. They don't do very well after linear on linear. That's why I've got that extra document that we've attached. But what do I think? I think if you can do 3 up to 3e and including, but it's a lot of calculator work. It doesn't take that much effort. Do you have to sketch every single graph? No. Just enough to make sure that you have a nice graph and you use your ruler. Does that seem reasonable, guys? So working your way through to make sure that we can get 3e done, and the rest will sort of come connected with that. Love you. Goodbye.